So guys, today let's see if we can solve, using chemistry, a very common computer problem that affects millions of households every year.
Oh no, we're operating on this computer.
Yeah, we have this old computer here, and it's really old, and it's time to recycle it. The problem is that we actually have, over the years, quite a bit of private data stored on the hard drive. So before we give it to someone for recycling, it's a good idea to remove that data from the drive. So you might think, well, that's easy to do. I'm just going to delete the files and empty the recycling bin and we're done. But it turns out that the data is actually still on the hard drive even after you do that. And I'm going to show you why. I'm going to illustrate it like this. So we have a file folder here, which represents a file on the disk drive. And it's got an index tab on it. This file name is passwords. Some of you have a file on your hard drive that stores all your passwords. Now, when we delete this file in Windows Explorer, for instance, what we're actually doing is we're taking this file name, this index tab, and we're getting rid of it. So at this point, it seems like the file's gone because you don't see it in File Explorer, but all the data is still on the drive. So we need a better way to remove all of the data from the drive. So what I'm going to do is I'm going to show you a way to quickly, safely, effectively wipe all the data from the drive using a bit of chemistry. So what we're going to do is we're going to start out with one of the most boring chemicals on Earth, and that chemical is iron rust. Do you guys happen to know what the chemical formula for rust is?
Iron and water.
It's iron and oxygen.
Oh.
So when you expose iron to water and air, the oxygen reacts with the iron and forms that reddish-brown compound, right? And so we have some iron oxide here, red powder, and what I'm going to do is I'm going to mix that iron oxide with some aluminum powder. So I have this big beaker of aluminum powder here. I just used a big beaker to make it easier to mix. So we're going to mix this together. And let's mix this up. Oh, I'm making a mess. Let's switch to a different tool. Let's use what's called a pestle. And this is a way to break up all the material and mix it better. And what I'm creating is I'm actually creating a compound called thermite. There's a Greek word therm, which means heat.
Yep.
And that's going to be significant a little later. So that's pretty well mixed. So in order to explain the thermite reaction that we're going to do, it's actually easiest to look at it at kind of the level, the atomic level. And so in order to do that, we need atoms. And so I kind of raided our sports bucket and I grabbed some balls that we're going to use for atoms. So this is going to be iron. This is going to be oxygen. So we put them together, we have iron oxide. By the way, any thoughts on why I made the iron atom bigger than the oxygen atom?
Because it is?
Well, the atomic number of iron is 26, the atomic number of oxygen is 8. So what does that mean at the atomic level?
It would be bigger than the oxygen atom.
It would be bigger because you have more protons in the nucleus, and more significantly, you have more electrons going around the nucleus. You have 26 electrons, so you actually have 4 energy levels or 4 shells for iron and only 2 energy levels for oxygen. So we made the oxygen smaller. So now I need another ball. Let's use a wiffle ball here. This wiffle ball is going to be our aluminum. Okay? Now, aluminum is actually a more reactive metal than iron. This iron oxide is a pretty stable chemical, but aluminum is more reactive, and if we can get this reaction going, we can actually have the aluminum break the chemical bonds of the iron oxide and pull this oxygen over and make aluminum oxide. And now what do we have left over here?
Iron.
We have pure iron. So we started out with something rust, this reddish brown substance. What's pure iron look like?
Isn't it silver?
Yeah, it's a silver metal. Now the other interesting thing about the thermite reaction is it's highly exothermic. So exothermic, what do you think that means?
It's very hot on the outside.
Yeah, the reaction gives off a lot of heat. In fact, the amount of heat given off by thermite is so hot that it can actually exceed 4,000 degrees Fahrenheit. It's one of the hottest conventional chemical reactions there is. The reaction's so hot that thermite will actually react underwater. And so, here's another question. So, we have this iron over here, and iron's melting point is about 2,795 degrees Fahrenheit. So it's about a little under 3,000 degrees Fahrenheit. And this thermite reaction's operating at more than 4,000 degrees Fahrenheit. So what state of matter is this iron going to be in? Is it going to be...
Liquid.
What?
Liquid.
It's going to be liquid. So we're talking creating superheated liquid iron. I'm talking about like molten rivers of metal. Is that going to be cool or what?
Yes, except it's gonna be hard. Can we smooth our smooth back now?
Okay, so what we're going to do is, oh, by the way, when I showed you that iron oxide, that's actually not exactly what iron oxide is. It's actually 2 iron atoms and 3 oxygen atoms, but I didn't have enough hands to hold all those balls, so I simplified it a little bit. But the same general idea applies. So what we're going to do is we're going to take out the hard drive of this computer, and I've already removed the mounting screws, so I can just slip it right out. And we'll just put it on top here. There we go. And let's mix up our thermite a little bit more.
You used to blow up the gunpowder?
Possibly, yes.
I didn't try that today.
Okay, so what I'm going to do is I am going to put about 10 grams of thermite onto this hard drive. There we go. And what I'm also going to do is, in order to kind of contain the reaction, I made this kind of metal frame, and I'm just going to put this over top like this. And then, why don't we add a little bit more thermite? Let's add maybe 100 grams. Actually, let's add maybe 200, well, 300. Well, 400 would be good. Well, okay, well, I'm going to stick to 500. There we go.
Oh my.
There. That's about right. So, the thing about thermite, which is kind of counterintuitive, is even though it gives off a lot of energy when it reacts, it's actually quite hard to start the reaction. And that's because iron oxide is a very stable compound. So we need to get the aluminum, the iron oxide atoms bouncing around really quickly so the aluminum can actually hit the oxygen atom, break it free, and start the reaction. So how do we generally get atoms moving quickly?
Fire?
Heat. We need to add heat. Okay? And there's actually a good way to add a lot of heat to get this reaction started, and that's to use magnesium. So what I'm going to do is, let's just start, make a little pocket there. We're going to put a little bit of magnesium powder in here. And then we're going to make a fuse out of magnesium ribbon. And you guys have seen magnesium ribbon burn before. It burns with this really brilliant white light, and it generates a lot of heat. And so that's going to be just a ticket for getting this reaction going. Now, we have quite a bit of thermite here, and so at this point it's probably worth talking safety. So what I'm going to do is I'm going to give you our plastic Lexan blast shields, okay? And you're going to use these to protect as many vital body parts as you can. Okay, now I would recommend you move back a little bit. Move back by the wall.
The wall?
Okay. There we go. Okay. So let's see.
Will it explode?
Why don't we get a torch going here? And I'll put on some gloves. And we'll see if we can get this lit.
Oh my!
I think our beaker didn't like that molten iron too well.
Oh my god!
So let's take a look.
Fire!
Let's take a look at what we have here.
What the heck?
So I'm looking at this disk drive, and mostly I'm seeing a puddle of molten metal in the middle of it. And we grab it.
What?
One of the things you're going to notice is actually the metal frame got welded to the disk drive as a result of the molten metal melting everything under the disk drive. So, oh, there it came off. You can see it's glowing red hot. So we're going to put that down, and let's take a look at the disk drive. So we actually, what I'm seeing here is that the metal melted right through the disk drive. You can see there, it's still glowing red hot. And you know me, I don't really understand all this high-tech computer electronic stuff, but I'm going to venture a guess that there's probably no usable data left on that disk drive.
I don't think it's usable.
I don't think it is. I'm pretty sure the manufacturer's warranty has been voided. So, we now are in a position to safely recycle this PC without the worry of any private data getting out there. And you know, another good aspect of this technique is that it's technology agnostic. It'll work on iPhones, Androids, anything where you want to remove the data. So keep that in mind. So, I think we're done. I think we achieved our purpose.